This is another coding interview question. It's a Google interview question and it's called path sum. It has to do with binary trees. We have a root for a binary tree and we have an integer called target sum. We have to return true if the tree has a root to leaf path such that adding up all the values of the nodes along that path equals target sum. A leaf in a binary tree or in any tree is a node without a left child or a right child. So it has to be on its own, no child nodes. In example 1, we have a tree. There are multiple levels. We have 5 as the root nodes, then 4 and 8 as the left and right child nodes, respectively. And then we have other nodes. The leaf nodes would be 7, 2, 13, and 1. So if we look at the target sum here, in the inputs, it's 22. So when we traverse that tree, is it possible for us to reach the target sum value? So here we have 5 plus 4, which is 9, plus 11, that is 20, plus 7, that is 27. It's not equal to target sum, so that is not the path that we want. We can check again, 5 plus 4, that is 9, plus 11, 20, plus 2, 22. So this path confirms that we can add up all the nodes in the tree from the roots to a certain leaf node and obtain target sum. So from that point onwards, we can keep checking the rest of the tree or we can simply terminate the operation. It depends how you code your solution, but basically we need to return a Boolean value, true or false, and here we have to return the value true. But for this tree, for example, we have 1, 2, and 3. The target sum is 5. That is what they have here. So if we do 1 plus 2, we get 3. Or 1 plus 3, we get 4. It's not possible for us to obtain the value 5 from the root to a leaf node. So there is no path that matches this condition. In this case, we have to return false. One last example, the tree is empty. Target sum is 0. We don't even have a value to add up. So we just return false. We can check again the structure of the tree. It's a struct, a C++ struct. It's called tree node. Every node has a value. It has a left child and a right child. We can create a node with a default value of 0 and without any child nodes. We can also assign a value to a node and we can assign a value plus a left child and a right child. So that's what this line does. Now I've explained my logic, how it works. I'm going to return true if the target sum reaches the value of 0 after I deduct the value of a node from target sum. If I continue deducting the values, then I'm going to get 0 normally if it's possible for me to find a path that matches the condition for this LeetCode challenge. So here we need to make sure that the moment we obtain the value of 0 after deducting from target sum, we reach a leaf node. If the node is not a leaf node, then it doesn't match the condition. So I'm going to have some print statements inside of my C++ code. And then when I run the test cases, it's going to be clear to you because we're going to see what is happening at every step as we descend the tree. This coding challenge is associated to depth first search or DFS, and that is a traversal algorithm. For trees, especially binary trees, we use them a lot, but you can use them for any type of tree. So once we return true, we're going to save the value in a member variable from the solution class, and then we're going to stop our computing for target sum minus a node value. So this here is the solution. Notice I've added this private member variable. It's a Boolean value and I'm calling it found. So I've added a constructor for the solution class just so that I can initialize my member variable to false. I don't want to initialize it here with the assignment operator. I prefer to do it with the constructor because LeetCode allows it. So here we have the Boolean function now. It's called hasPathSum. It takes the roots of the tree and then the target sum. So again, the root of the tree would be 5 in this case, this root node, and target sum would be 22. So here I'm going to check if the root is valid, meaning it's not null, and I've not found my path yet, then I'm going to do something in here. Otherwise, if the root node is not valid, or whichever node we are at, because this is a recursive function, so whatever nodes we are at currently in the recursion, if it's invalid, then we're just going to return false. So immediately, this tells you that we are able to match this example, because if the tree is empty, we automatically return false. Now, what do we have to do when a node is valid? We need to check if we've not found the path yet, then we need to deduct the value of the current node from target sum. And then if we reach 0, then we need to check that we are at the leaf nodes. So here, notice that I have exclamation marks. Here I'm saying if the left child is invalid, and if the right child is invalid, meaning both of them are null, it means that this node, this current node that we are calling roots, is a leaf node. So if we reach the value of 0 by the time we do target sum minus the node's value, it means that we found a path, and therefore I can return found. It's the same thing as saying return true, but I'm just storing this value true inside of my Boolean member variable found because I need this for this condition here. Remember that this here is the outer condition, the outer if statements, and this one here is the inner condition. So if I've not found my path yet, then I'm going to explore my tree using a DFS algorithm. So I'm going to pass the left child of my nodes, and then I'm going to pass the updated value of target sum. The updated value is target sum minus this node's value. And then I'm going to keep exploring on the right as well. And then I'm going to return found. So whatever that is, I'm going to return it. Otherwise, if I've not found any path yet, then this will be equal to return false. Now, when I run this code, you will see that we're going to pass the test cases. But if it's not clear, I'm going to enable the print statements, and then you should be able to understand what is going on. So here we've passed everything, but let me drop this down. And then I added some statements here. So I'm saying current value equals the node's current value. And then in between parentheses, I'm going to print the updated value of target sum, which is target sum minus the node's value. So I'm going to print it for this else statement here, and also when we find the path. So now that I have these two statements, I'm going to run this code again. I'm going to bring this up so that it's clearer for you to see. All right, so notice that case 1 is this tree right here. So we are dealing with example 1. When I drop this down, we have true. And at first, we are at the node with the value number 5. So I have current value 5. When I do target sum minus the node's value, I get 17. So from 17, I now descend to number 4. Now the current value is 4. When I do 17 minus 4, I get 13. Now we descend to 11. We are at 13 for target sum. So when we do 13 minus 11, we get 2. Meaning that now all we need is a node with a value of 2 so that we can reach 0 at the leaf nodes. So we descend to the left. We get the node with the value 7. This gives us -5. Then we return because it's a recursive function. So we return here. We visit the right node because here, if you check my else statements, where I'm highlighting, we first descend to the left before we visit the right. So when we are done with 7, we still haven't found our path. We return to 11, and now we have to visit the right, which is the node with the value 2. Now, when we were at 11, the target sum minus the node's value was 2. So when we do 2 minus 2, we get 0. So at that point, this condition here evaluates to true because we get 0 here, and our node with the value 2 is also a leaf node because both its left and right node pointers are null. At that point, found becomes true, and for any other functions on the call stack, we just return the value false, because for the rest of this function, when it gets executed, this is going to evaluate to false, because by now, found has become true, and here we're using the AND operator, so both of them have to be true for this outer function to run. So that is it. I'm going to remove these print statements, and then I'm going to run, or rather submit this code. So I'm going to drop this down, and now let's click on submit. All right, so that should be it for the solution. Occasionally, you're going to get much faster speed. So for example, in my previous submissions, if I go here, you can see that at some point I got 8 milliseconds, which was faster than 96% of all C++ submissions. So it doesn't really matter for the speed because it's still accepted, but you guys can speed this up so that we don't even visit the other nodes. So it's up to you how you want to do it. I'm using a DFS-based algorithm. It's a recursive function, and I'm using a member variable to reduce the processing time. So that's it for this solution. If you guys like my LeetCode tutorials, you like my Google interview questions and answers, and you like my channel, please subscribe and I'll catch you next time.